Okay, in this video we'll talk about contact angle and what it means with respect to the phenomenon of capillarity, which is why liquid rises up a straw. Um, so you will often find that if you stick a thin enough straw into a liquid pool, then liquid will rise up the straw by some height h. Why is that? Um, that's because liquid molecules actually like the material of which the straw or needle is made of. So if we zoom in again to a molecular level, then if you look at attractive forces between molecules, sometimes these forces, which are called cohesive forces when they are the same kind of molecule, these cohesive forces may not be as strong as adhesive forces, which are interactions between different molecules. So when you have a situation where the liquid has a choice of either interacting with itself or interacting with this other molecule from another material, then it prefers to interact more with this other molecule, and as a result, it tries to maximize its interaction by rising up that straw or that needle. How high does it go? That depends on the degree to which it likes the other molecule, and which is essentially a measure of the surface tension and the interaction between these two. One way to figure that out is to quickly do a force balance. So if you were to look at just the meniscus, so if I were to zoom in on that area, I would see I would see essentially a spherical meniscus, and there's a force, a surface tension force at that interface which is pulling up all this liquid up so that the interaction can be maximized. So if I do a force balance, that force at the interface times the contact line length gives me the work done to pull up all this fluid that it is holding in place. So a quick force balance would give me, if this radius of this tube, let's say where r, then I would say pi r square, that's the cross section, times h, that's the volume, times rho, density, so this whole thing is the mass, times g, that's the total force. That force is equal to the surface tension force, which is given by sigma times the length of the contact line, which is 2 pi r. And so I can say H equals 2 sigma over r rho g. So the higher the surface tension and the smaller the radius, the more that height will be. That this analysis assumed that the contact line here is perfectly tangential. Often the case is that there's actually an angle here, theta, at which that contact line lies. And so instead of 2 pi sigma times 2 pi r, we would, if we were taking just the vertical component, that we would replace this with sigma 2 pi r times cosine theta to reflect that we are balancing forces in the vertical direction. And so in that case, we would get a term cosine theta there. So that contact angle there that we talk about is really measured inside the liquid. So if you put a drop in the liquid, a drop of liquid on a surface, that angle is the angle that the drop makes with the surface. When that liquid really likes that surface, that angle will be positive, but when that liquid hates that surface, that angle might be actually negative. You might actually get a situation where a drop looks like that. The angle is still measured from inside the liquid. So we get what is called either a hydrophilic behavior or a hydrophobic behavior. Hydrophilic behavior means theta is less than 90. That means that adhesive interactions between the liquid and the surface are dominant because the liquid is trying to spread itself. And when the angle is greater than 90, like here, it's clear that the liquid wants nothing to do with the surface, and it's trying to bunch itself up to minimize the area of interaction. That's when cohesive surface interactions dominate. So this case where water or any liquid rises up the needle or straw is a case where clearly adhesive interactions are dominating. If you took, let us say, a glass tube and stuck it instead of water, if you stuck it into mercury, you'd find that instead of the fluid rising, the fluid would actually be depressed. And that's because mercury wants nothing to do with the material, which is typically glass. So you can have situations where you get a depression of fluid. So depending on the contact angle, you can get a variety of phenomena.